Unit 6, Quadrilaterals and Other Polygons. We're in Lesson 6.2. This is Part 2, Kites. Objectives for Part 2. The students will be able to recognize and apply the properties of kites. Definition of a kite. It's a quadrilateral with two pairs of consecutive sides congruent. So here we go. We have them marked. We have two pairs of consecutive right after each other sides that are congruent. Properties of kites. A kite is a quadrilateral four-sided figure with the following properties. Exactly two pairs of consecutive congruent sides. So segment AB is congruent to segment AD. Those are consecutive. They're also marked. Segment BC is congruent to segment DC. Those are congruent in green. They're also marked with two slashes. One pair of opposite angles are congruent. That's those two right there. That is angle ABC is congruent to angle ADC, and diagonals are perpendicular to each other. So, of course, it makes four right angles in there, four right triangles, two pairs of congruent ones. We'll use all that. Kites. Examples. Each quadrilateral is a kite. Find the missing value. Show all work. Mark information on the diagrams. So in the prior lesson, we know the measures total in a quadrilateral to 360 degrees. And we have two of them that we know. So 360 minus 85 minus the 43 gives us 232. Now, angle B and angle D are the two congruent angles in the kite. So we can take our 232 and divide by 2, and measure of angle B and measure of angle D is 116. In number 2, measure of angle J and measure of angle L are congruent, so that's 32. All the angles total 360. Get rid of the ones we know, and measure of angle K is 125. Number 3, we are given measure of angle QPT is 37 degrees. Let's see what we're looking for. Measure of angle PTQ. Okay, that's 90. That's simple enough. The diagonals are perpendicular. Let's see what else is left. Measure of angle PQT and measure of angle QRT. Well, measure of angle QRT is the same as the measure of angle QPT, so that's 37. So if we subtract the 37 from 90, because the acute angles of a right triangle are complementary, we get the last angle that we need to know, which is 53. Number 4, we are given measure of angle GGH is 59 degrees. So we know there's another one just like it over there. Those two triangles are congruent to each other. Let's see. Measure of angle GGE. Well, that must be the sum of those two, 118. Measure of angle DEH and DGH. Those are going to be congruent, and they are acute angles of a right triangle. So 90 minus 59 is 31, and that's the measure of the last two angles. Number 5. Let's see, same directions. They have a lot of information that we need to find. I think the easiest one is measure of angle 3 is 90 degrees. So we have 4 right triangles. That's probably going to help us out. Measure of angle 4 is the same as 65, and measure of angle 7 is the same as 52. So let's get in our 65 and our 52. Acute angles of a right triangle are complementary, so we can find some other ones. 90 minus the 52 is 38, and that's going to give us measure of angle 5 and 6. Those are congruent. If we do 90 minus the 65, degrees, we get 25 degrees, and that gives us both measure of angle 1 and measure of angle 2. Number 6, if WX is 14 and WR is 8, we need to find the length of segment RZ. So that is right triangles, 4 right triangles in there. The diagonals are perpendicular. Length of segment WX is 14. So length of segment WZ is the same. Length of segment WR is 8. And we need to find the length of segment RZ. We have a right triangle in there. Let's pull it out. Ooh, Pythagorean theorem. Let's go. Measure of angle RZ is the square root of the hypotenuse squared minus the leg squared. Put it into Desmos and we get about 11.5. It does say round to the nearest tenth if necessary. Another one, number 7, same directions, I believe. Length of segment RS is 10. Length of segment RU is 9. Find the length of segment QS. That's that whole thing right there. RS 10, RU is 9. Right triangle. Diagonals are perpendicular. That's what gives us our right triangle. Pull it out. Pythagorean theorem once again. But length of segment US is on our right triangle. And we want QS, which is going to be double that. So let's do 2 times the square root of 10 squared, hypotenuse squared, minus 9 squared, the leg squared. Put it into Desmos. We get about 8.7. Number 8, finding the measure of angle L. Now those two angles are equal to each other. So let's set them equal to each other. 5x plus 23 equals 8x minus 31. Subtract the 5x on both sides because it's the smallest. We get 23 on the left equals 3x minus 31. Add 31 to both sides to get rid of the minus 31. We get 54 equals 3x. Divide both sides by 3. X is 18. But we want the measure of angle L. So we do have an expression for that. 5x plus 23. Plug in the value we got for x, which is 18. And we get the measure of our angle as 113 degrees. Number 9, we're also looking for the measure of angle. Measure of angle STV. Okay, that's going to be the same as the measure of angle VRS. Now the two that are marked are going to be complementary to each other. So they are going to add to 90 degrees. Let's see, there's a right triangle. Acute angles in a right triangle are complementary. So those two. So complementary angles, everything from day one's fair game to angles with measures totaling 90 degrees. So 9x plus 1 plus 23x minus 7 equals 90. Combine like terms. 32x minus 6 is 90. Add 6 to both sides. 32x is 96. Divide by 32 and x is 3. Not our final answer. We want the measure of angle STV. That is the same as the measure of angle SRV, which has an algebraic expression, 9x plus 1. Let's plug in our 3 in place of x, and the measure of our angle is 28 degrees. Here's just a review of some properties. We haven't gotten to all of these, but I'm sure you know some of them. Square, all the sides are equal and all the angles are 9 degrees. We actually used it a little bit in the last unit. Rectangle, opposite sides are equal and all the angles are 90 degrees. Parallelogram, opposite sides are equal and parallel. By definition, it's parallel. Now the green's arrows mean those two are parallel. The purple mean those two are parallel. If you're writing it on your paper and not using color, you should probably use 2 arrows, double arrows on one of those sets. Let's see, trapezoid is how we call it. Trapezium is in the UK, but 2 sides are parallel, and that's those 2 right there. A rhombus, all sides are equal to each other. Opposite sides are parallel because it's a parallelogram. Opposite angles are going to be congruent because it's a parallelogram. Let's go to kite. Let's see. Adjacent pairs of sides are equal. We just covered. We have now finished Lesson 6-2, Part 2 of Trapezoids and Kites. We've been studying kites.